This is the 2D visualization with the ArcGIS API for JavaScript. I'm Jeremy Bartley.
And I'm Kristian Ekenes.
And we have quite a few things to show. I think we've got a lot of content. We'll just blast right through.
Right.
Yeah. Do you want to talk about this one?
Yeah. So we just wanted to point out that the visualization capabilities between the 3x and the 4x APIs are not at parity with each other. As you probably already know, we have our 3.20 API out, which is all the functionality that we support in ArcGIS Online and elsewhere. And then we are currently spending most of our efforts developing 4x, but we don't have all of the functionality in there yet. And so that includes visualization on the 2D side. And so we're gonna put these little markers in these slides to let you know that when we're showing you a visualization, that it may only be supported in 3x at the moment. And when there's a visualization that shows up, we'll have a 4x symbol to indicate that it's there, but there might be partial support. And that'll make sense when you get there. So just keep that in mind. If there is no marker, then it's supported in both APIs.
Yeah, and then even if it's not there, a lot of the concepts are pretty much the same. It's just the fine details of how you actually code it. Okay, feature layer. Feature layer is really the layer that works with your data. It queries the service, accesses that JSON, brings it back to the client, and draws it as vector data, either as SVG or Canvas, or as Jan showed, where we'll draw it in WebGL. It can be interactive, and of course it has pop-ups. You also can use the feature layer to query, so you can do interactive queries to pull back data and create those visualizations. It's also the gateway to doing editing, so you can work with features to edit it and then call apply edits on that feature layer, which will push it back to the service. But the main thing we're going to talk about today is the various ways to visualize a feature layer. We think we have a pretty sweet platform for visualizing, creating interesting 2D visualizations and 3D visualizations, but we're just going to talk about the 2D, and we'll hope you'll learn about it. It all starts with renderers, so we have some of the basic renderers. Simple renderer, which just draws a single color, unique value, which breaks it up in types, and class breaks renderers. The default feature layer just has its own default symbol defined in the drawing symbol. So you basically take a URL to a layer in a feature service or a layer in a map service and just add that. And even if it didn't have any renderer defined, it would draw. But where it gets interesting is where we start to talk about breaking it down into different aspects. So show me where. So you don't really have. You're really just looking at a location. You have a simple renderer to show you a location of where something is. And did you want?
Yeah, in this sample, we're just visualizing cities in the world, and if you're just doing simple location, you're going to set one symbol, and in these 4x in these code snippets, if it's in 4x, we're going to show you the 4x snippet. It's a really clean way to show off what you can do. So for the simple renderer, you're mainly dealing with just one property, and that's the symbol property. And so you can pass in any supported 2D symbol, in this case, a simple marker symbol. And then you can set, the size of it, the color, and then an outline. And so if you're familiar with the 3x API, you might have to import, simple line symbol for the outline and simple marker symbol for the symbol and color. You don't have to do that in 4x because we autocast those objects, and that's what's really nice about this API is it makes it really clean and simple to set a color and outlines on these symbols.
Okay, now show me what something is. So here we have an example of major roads, and we've just broken it down into 3 classes.
Yep. So if you hit the next one to show the code snippet, again, this goes to show how nice this API is compared to our 3x series. Normally you would have to set or call like add unique value info or whatever the method is called in 3x to add these infos or these classes, or I should say unique values to the renderer. In this case, you can just pass in an array of objects to indicate those. So I'm setting a line symbol and setting it at very different colors and widths to indicate which class of road it is.
Another sort of like tangent to this is that what we're going to show you today is everything you can do in code, but you really should leverage the capabilities of either reading a web map, where the web map has everything defined and you use the user experience to set it, or you've created a layer in your portal or an online and you just load that layer into the API. That's a great way to reduce code. Like I look at this and I would hate to write all of this.
But if you had to,
you
could do it, and it's not that bad. So.
This is true. This is true. All right.
Okay, so when we talk about data-driven visualization, we're talking about visualizations that are driven by a value, and that value can come from any number of sources. And most of these samples we talk about getting a field value, but there are other places that you can get them. And one of those new features that you have in the API to generate a value is with an ArcGIS expression. You can also generate it with a JavaScript function, and Jeremy's going to show that next. But ArcGIS is a new expression language that can be read across the platform, understood in ArcGIS Online, JavaScript API, Runtime API, ArcGIS Pro, and so it provides a consistent way to generate values that you can define that you can generate by, like, say, performing mathematical operations on field values. So in this case, we have a predominance renderer showing the majority or the different political parties and which one has the majority in each county. So in some areas you see along the Mississippi River, it's Democratic counties, even though it's the Deep South, so that's interesting. You see a bunch of Republican dominated counties all over, and then even some independent or third parties going up in the Midwest there. And this is not generated from a field value. It's where we have 3 separate fields in the feature service, and what we're doing is comparing the values and then finding which one is the highest and then returning a string indicating what field that came from. And that's how we set up the unique value renderer there. So again, as Jeremy said, you can actually author these in ArcGIS Online, so you don't have to do it in a custom JavaScript app. But if you do, we have a session tonight at 5:30 that I really encourage you to go to, because we're going to go through this sample and a lot of other visualization samples generated from ArcGIS, and it's really powerful. So,
do you want to say anything about how you're using opacity in this sample?
Yeah, absolutely. I actually will later on in this session. There's a...
You want like a teaser?
Yeah, so it's interesting to show, which party wins, so to speak, when it comes to registered voters, but you might also want to know how much they win by. So if this were election results, they might win in a certain area, but did they win by a large margin, or was it a very contested or close race? And that's where I'm using opacity. If it's a very opaque feature, that means that party dominates. If it's very transparent, then it's almost a toss-up. They're almost equal with another field, or maybe both of them. So if you look at Wyoming there, in central Wyoming, you can hardly tell that it's dominated by Republicans there because of how transparent it is. And we used an ArcGIS expression to generate that as well.
But like Kristian said, we'll talk about opacity later. You can also do the same thing outside of ArcGIS, but using a JavaScript expression. Now, this is not portable. This is something that only would work in your application, whereas ArcGIS is portable and can be brought in, saved in web maps and so on. So that you can either have a renderer that references a field, like in this case, this primary care physician's rate, or you can have a unique value renderer that references a function. And this function will get executed every time the layer is trying to draw for each feature. So here's an example showing, I think this is alcoholic spending per person compared to the national average. And so anything that is red is above, anything that is blue is below, and anything that is gray is similar. Let's go to this app. And then it allows you to build interactive applications to sort of, let's say, reset it. So by clicking here, the alcoholic spending per person is compared to this particular county. And notice how as I move around the map, click different places, those colors are going to change. Whoa, Denver spends a lot on alcohol. San Bernardino, more normal, is where we live, yeah. If we look at the, I can't remember, is the code in the, yeah. If we look at the code, it's pretty straightforward here. We've got, this is an old 3x style example, so I've got 3 unique values. I got a value above, that's red, below, that's blue, and similar, that's gray. Okay, so that's just basic unique value renderer code. And then this is where all the magic happens. So it takes this function, it's going to return you a graphic, and from that graphic you can pull out the value, spending per person. And then if the value is greater than the average, now in this case average is some global variable accessed through closure outside of this application, within 0.5%, then I'm going to call it similar. If it's above, the value is above 0.5%, then I'm going to call it above. Otherwise, I'll just return below. This is an example of a use case that might be complicated to do with Arcade, because you'd have to change the Arcade expression every time the user clicked on it, because in this case I started with average, but every time I clicked on the map, I changed that average to be some other variable.
Yeah, if you're accessing values from outside of the feature, or changing values, or maybe you want to compare one feature's value with other feature values, say, or like maybe the neighboring features, then it does get more difficult with Arcade. It only really operates well within the context of one feature.
And this kind of thing, this technique can also be used to, let's say you have all the counties, and then you have monthly values of, let's say, spending per month, and you want to map a particular month or map the average value. That function can do the summary on that multiple dimensional table and just return the one value. So that technique can help you in code work with a one-to-many relationship and still map it. Okay, show me how much. Everything, that example I just showed for unique value can also be based on an expression or a value or a function.
Yeah.
So you have many ways to do it. So by either color, size, or opacity. And or rotation. These parametric properties on the renderer, these can be applied to any renderer. So I could use a unique value renderer and then size it and color it differently. Well, color wouldn't really make sense, but I could size it and apply opacity. I could rotate the markers for that unique value renderer and so on. This is really the new pattern that we recommend you mapping thematic quantitative variables is to use the visual variable pattern. So let's talk through that. First, let's talk through the class breaks. So this is an example that probably most of you are familiar with, and actually I'll let Kristian say it since you.
Yeah. This is if you have any. How many of you are geographers by chance? Your GIS, cartography. Yeah, so a number of you. If you've taken like any sort of GIS course in school or any training course, you're probably used to seeing this for visualizing numbers. You set up class breaks. You have different kind of classification schemes like natural breaks or quantile or equal interval or manual, as is the case in this one. And that works really great for paper maps because it allows you to easily categorize features in your map with a specific color. But when you're working on the web, that's when the visual variables and the continuous colors and sizes really work well, because you get to see more detail If you really want to know the specific value for a feature, you can touch it and get a pop-up. But you still can set this up on the web, and if your app or your organization requires it, you can do it. And similar to the unique values, you just set up class break infos, where you set a min and max value, you assign the symbol, and then you can assign a custom label as well. In this case, we're looking at the percentage of the population who has a college degree in the Seattle, Washington area.
Now, everything that Kristian said is definitely true. Writing a class breaks renderer in code is very tedious and time consuming, and it's also, how do you know what to set these values? And if I make this one 0.37, then I got to actually update this other one. I mean, it's what a pain. And classification is in general a hard technique for people to understand anyway, because how many classes do you pick? Do I pick 4 classes? Do I pick 7 classes? Which one's better? Why does 0.3499 get one color and 0.35 get a different color? It's fairly subjective actually. But if you make it non-subjective and you make it quantitative, you use techniques like natural breaks or quantiles, like Kristian said, standard deviation, and those are even harder concepts for people to understand. So this can still be done, and if you're going to be printing to PDF, this is probably what we'd recommend, because you're going to get the best printed map. But in the digital world, I think we have some more techniques we can leverage.
Mm-hmm. So this one shows how you can make it simpler using continuous color. So in this case, we're looking at the percent of the population in poverty in the southeastern states, and what we're doing is instead of bringing in a class breaks renderer, we're just using a simple renderer, setting a default symbol with the symbol property, and then we're using visual variables. And in this case, we're just going to set the type to color, and notice that I do set a color in the. I don't set a color on the symbol, I set an outline color, because that's not going to be driven by the visual variable. But I don't set that color inside the default symbol, because it's going to be driven here in the visual variables. I set my field a normalization field, so I have my normalized data, and then I just set a number of stops. In this case, we're setting bounded stops, so a bottom stop and a top one. If the population, the percentage of the population is greater than, 30%, then we're going to have that as the deepest purple color, and then we're going to gradually change that color down to the bottom if they fall anywhere between 10% or 30%. So you can see you get a lot more detail. It makes for a more interesting visualization than that Seattle sample. And if I want to get those values, I can get access it through the pop-up. And similarly, instead of using a field or normalization field, you can set an ArcGIS expression in there as well.
Cool. And the stops can not just be like the start and stop, but you can also set a stop which changes the color completely. So like in this example, which shows you, what is this showing? Retail spending, average retail spending. I think the average for this data set is 22,000. So what we're doing is we'll set the lowest value to be blue, we'll set the average value to be white, and we'll set the largest value to be red. And this allows you to focus or pivot on a particular point. You might have faked this out in the past using a standard deviation class breaks renderer. But this is the more natural way to sort of pivot on an interesting value.
Yeah, and that's a 3x snippet. So notice that you don't have to call set visual variables in 4x, and here you do. And also using the color module, you don't need to say new color in 4x like you do here.
Okay, let's talk about size, both real world and driven by variables.
So here we have a data set of trees for a college, and we want to symbolize the marker by the canopy size as it is in the real world. And so instead of setting stops, we can actually take the value of a field that indicates that size of the canopy and use that to drive the visualization. So if you look at the visual variable there, for the field, we set it to that field that has the diameter. And then notice the value unit is set to feet. That's because it was measured in feet, and so we can set a unit there that will scale the symbol appropriately.
Let's see if we can show that. We have that sample, right?
Yep. So if you just go to the 4x.
Uh-oh. Where did my network go? Just lost the internet.
There, I got it.
The heck?
Are you on Wi-Fi?
No?
So notice that as I zoom in, the size of the markers don't change like they would, like if you set a standard pixel size. If I set it to a fixed pixel size, these would be changing as the scale changes. In this case, they're not because they're real world sizes.
Maybe I was on Wi-Fi. Okay. Oh, here, you can go ahead, actually.
You want to talk about this one, Jeremy, or?
Okay, yeah. Okay. Okay, truly proportional. So in this case, this is more of a traditional cartographic technique where you have truly proportional circles. And basically, what it means is if all you do is this is percent population and poverty by county, and it's a size, and we're doing this population value by county, and we're saying that the smallest size dot is going to be 1 pixel, and it's going to represent a value of 100,000. If the value was 200,000, it would be 2 pixels. If it was 300,000, it'd be 3 pixels, and so on. This can work in certain cases, but can easily sort of be you have too many orders of magnitude difference between your smallest value and your biggest value, and it would end up being very large representations. And this also doesn't work for like widths of lines and so on. It's really just for points. Yeah. Is there anything you want to show there?
That's not the next one.
Okay.
So then you can, so this is similar to is it on my screen? Oh, it is. Okay. So instead of doing the truly proportional, you can similarly set the stops for size like you would color, just set a value and then set it to a size in pixels or points. In this case, we're using points by default, but you could pass in a string and specify pixels, and that will work in the 4x API, not the 3x API. But in this case, we're looking at, again, the percentage of the population in poverty. Generally, when we're doing marker sizes like this, you would probably not necessarily need to do a percentage. You could do a total count. So we could move this field take out the normalization field, and then change the values. So I'm not exactly sure what the stats of this are, but I can take a guess that, say, if there's more than 25,000 people in poverty, they're going to have the highest size, and then if there's fewer than 1,000, then they're going to have the smallest size. And I'll refresh it and see what it gives me. So you can tell a little bit of a different story. Instead of the percentage of the population, which is interpreted better with color, you can get total counts that will show where the most people are in that demographic. So yeah, there's that code.
Still don't have my internet back, but that's okay.
Okay.
There we go. Now let's do the same thing, but apply it to linear features like highways. Again, very simple. These are polylines. We have a simple renderer with visual variables. We're going to size them based on the average daily traffic. But we're going to set some bounds on it. We're going to say anything less than 1,000 is going to be sized 1. Anything more than 100,000 is going to be sized 10. this bounding allows you to remove the effect of outlier-driven cartography. In a lot of cases, you can have some very big outliers, but those outliers aren't really significant to the visualization, and you're better off grouping them into a single maximum size, and that works pretty well for data sets like this, or data sets that are highly skewed in one way or another. I think you'll have to show the, oh, you've got it, okay. Yeah, let's just switch. Or let me say. Now, with size, size is an interesting one. When you're doing thematic size, as you zoom in, you actually want to change the size to make the visualization look good. You want to basically have the average value fit into, take 75% of the average size of a feature as it's drawn on the screen. So the smart mapping tools will actually do what I just said and give you a set of sizes. But as you zoom in, the average feature size is going to get bigger and bigger and bigger as it is on screen. So really want the map to look good on all scales. And
I'm demonstrating that right now. How if you don't change the size, it
doesn't it doesn't look very good. And then do you have the other example?
Yep.
And so as we zoom in on this map, notice the legend. It's going to get a little bigger at each scale level. Now, within a scale level, it's all consistent. But as you zoom in, we want that to look like a pretty good map. You want to show the code snippet for that one, Kristian?
For this one?
Yeah.
Yep. Notice the outlines too of these polygons. They get a little thinner.
And eventually go away.
They eventually go away completely here. So it makes for a better visualization. And
so basically, instead of min size and max size being an actual value, they're going to be an object which contains another size info. But the size info that's being the data that's driving the size info is not a variable in the data set, it's actually a variable on the view, or in this case, the scale of the map. So as the scale of the map changes, we have different sizes that we want to use for the min size and different sizes that we'd want to use for the max size. So at the very largest scale, like 1 to 1,000, then we want the min size to be 16 and we want the max size to be 80. But at the sort of global scale, we want that min size to be very small too, and the max size to be 25.
So yeah, this takes a little bit to get used to, because these values are not your data values, they're the actual view or map scale values. The data values are going to be up here in the min data value, max data value properties.
Cool. Rotation. All right, next example would be rotation. So with rotation, it's pretty much like it sounds. It's a visual variable where it drives the rotation of the variable from an attribute, in this case the heading. So you'll see this used in a lot of places to, especially if you have objects moving, to point in the direction that it's moving. In the plenary example, I gave an example of using rotation thematically. So the arrow, remember, if it was all the way to the left, it was for one party. If it was all the way to the right, it was the other party. And if it was straight up and down, it was a close race. So rotation is a pretty powerful technique. Do you have any examples you want to show?
No.
No, okay. Okay, I didn't know what you were going there. And then opacity. Opacity is another aspect that you can use. Basically, opacity is going to make things more transparent. So if it's fully opaque, you can't see through it. If it's just a little bit opaque, then you can see through it easily. So that makes for interesting visualizations. Kristian showed it earlier on that first map. Here's an example of, I just have a blue, simple renderer, everything is blue, and it's showing the precipitation index. And if it's a precipitation index of 10, then it gets a solid color, otherwise it sort of fades away. And just like the other variables, you specify the type and point to the field that it works on. And opacity is either 0 or 1. So if the value, in this case, the value is 0, opacity is 0, value is 10, opacity is 1, and it'll just scale proportionally in between.
So yeah, this sample is the same as before. That's what you get when you don't include opacity. You still have a story to tell, the winner, but then if you hit the next one, Jeremy, you get a better story or a more, I guess, accurate story of what's going on in each county. And then if at the next one on the code snippet, I'm actually using Arcade here, so instead of using a field value, a normalization field, I'm passing it to the value expression property. And the value expression title is what's going to be used in the legend. And you'll notice that the expression is coming from another script element that I'm calling strength. So if we switch over to my machine, this is the actual sample in our documentation. And right here is the Arcade script that I wrote for the winning party. As you can see, it's pretty simple. It's just 4 lines here and then returning one function down there. And then here's the strength one. Again, a pretty simple, straightforward example. Again, we're going to go over this in more detail in the Arcade session at 5:30 today. But essentially, I'm just getting the percentage of the winner and dividing it by the total. And that's what's going to drive that visualization. So down here, when I set the opacity visual variable, I'm going to map it to those values. And again, as Jeremy said, it's kind of hard to tell what, even in the visual variable case, what opacity or size or color stop values to use. And that's why ArcGIS Online is a big help. And that's where I actually got these, is I used the smart mapping tools in there to generate these. But this is how you would do it in code if you had specific values that your organization required you to use.
Do that. There you go. Next one. Yeah.
Okay, so because you'll notice that the visual variables property and the render has an S on the end of it. It's not one visual variable, but you can have more than one. And in that case, you can use several. You can use actually any number. You can put in rotation, opacity, size, and color all together. I typically don't recommend that because it makes for a difficult story to tell with your visualization. And that's what it's all about, is if you're communicating a good message, or the message you're communicating is obvious, then it's a good visualization. If you have your users or the people reading the map asking questions, what am I looking at all the time, then it's probably not a good visualization. In this case, I don't have a legend, so it's hard to tell what you're looking at, so it's not really telling you much. But in this case, I have 2 visual variables, color and size. Color, so you'll see several patterns. You see a pale color there in the Midwest, and it gets darker as you go to the Northeast. That is being driven by, I believe, the percentage of Democrats that live in those counties. And I set those stat values to 33 and 53%. I'm normalizing by the total population. So that's color, but then I'm adding size on top of it. And that's just the total population, or it's the population density. So if we look back at this, you'll see where the more densely populated counties exist, and that's where the Democrats tend to be more dominant, whereas the Republicans tend to be more dominant in the rural counties. And then when I set it in the renderer, you're just going to pass both of those visual variable objects into the visual variables property. It doesn't matter which order you use, it'll work the same way. So pass back to you.
All right, show me when. So it's not even just restricted to numeric data, but also temporal data. So treating date fields like as something that you can thematically map. So you can do things like a timeline where you, with a start and end date, or before and after a particular date where you might diverge from. Let's look at an example here. I think this is road networks in Minneapolis. And when it was when the last maintenance value was. So in this example, we've got the maintenance date, which is set to a particular time. And then we have the last maintenance value, and then that's the field that we're mapping and comparing it to now. So in this case, to make sure I understand this one, Kristian.
It's essentially showing the age. When was the last time it was serviced or inspected? So the white lines there are going to be older, whereas if it's closer to now, they're going to be darker. So that the white lines might be the ones that require more attention.
Yep. Yes. It's a different way to think of date. I mean, you might not typically think of a date field as something you would map thematically, but it can be pretty powerful and interesting way to look at it. And then the above and below can also work out. So you could have a third stop where you actually have a particular date of interest, like before or after the bombing in World War II, or something like that.
Yep.
Then there's a whole suite of other renderers which are only in 3x as of now, and we're evaluating for 4. Starting with dot density. Dot density is an example of a type of cartographic technique where you draw dots in polygons based on an attribute value. So in this case, I think we have census tracts, and the census tract has the Asian population. And in this case, 1 dot equals 100. So for every 100 people in that Asian population, we're going to draw a single dot, and it presents a pretty interesting visualization. We see on Southern California has a high, lot of places where people sort of congregate. In the case of the Chinese or the Vietnamese, they congregate in a particular area, or even Korean, you see the green there. But we see for Filipino, no, they're all over Southern California, and same for Japanese for the most part. And it's actually quite simple to create this type of visualization. So it's a dot density renderer where you identify the things that you're mapping, and with different colors, and you're going to say the dot value is going to be 100 and the dot size is going to be 2. You could even get crazy and represent 1 dot for every value, like in this map. I think the red is owner occupied, the blue is renter occupied, and the green is vacant. Another example that we explored in 3x, which I'm not sure how well it worked, but is the notion of a blend renderer. This is similar to dot density, where you look at 3 different attributes, so owner occupied, renter occupied, and vacant, but you use opacity to as the thing that blends the colors together. So if something is a very solid red, then you know it's pretty much all of that type. If something's all of owner occupied, or excuse me, renter occupied. If it's a solid blue, it's all of owner occupied. If it's sort of a mix, then it's blending out into, it's almost like an average.
Like a faded purple color, kind of.
Yeah. This works pretty well on a map like this, which is showing you the minority population in the US. So blue is African American, green is Hispanic, red is Native American, and purple is Asian. So it can lend itself well to a certain interesting visualizations like this one.
Yeah, I think it makes for some attractive visualizations, but it seems like more cases than not, you get really ugly ones as well, or ones that don't communicate well. I know that when I've tried out Blend Render, I've come out with visualizations that turn out to be lots of fall colors, and you don't see patterns, like muddy browns, and it depends on how many fields you're using, and seems like if you use 2 or 3, I think a max of 3, it tends to work well. This one is kind of that, like Jeremy said, the exception where you have more than 3 and it tends to work okay. But if you have more than 3, it's going to turn out to have a lot of muddy colors, and you can't tell which fields are blending with which other fields. So just, be careful when you're using this one.
Yeah. Maybe, oh no, since my internet's still not working. Better not go try to show one. This one could have just as easily been a predominant style.
Yeah.
Probably would have looked even better. Heat map renderer, this works well for data where you have lots of data. Then you want to highlight the density of the data. I'm always not really liked heat maps, but there are cases where it can be pretty interesting. We've always, like you guys have probably noticed, Esri demos earthquakes a lot, world earthquakes, and that's an example where a heat map really hit me that it was useful. We'd always see the global earthquake example, and you'd see all the earthquakes in the Pacific and maybe in Southern California, and fairly interesting. But then if you put the heat map on that, actually the highest density of earthquakes in the world is in northern Oklahoma and southern Kansas, where they're doing fracking. And I totally missed that visualization because all the points were just drawn on top of each other. So a heat map can provide some useful information about what's going on in certain areas, especially if you have lots of data overlapping. Okay.
All right, so you've probably heard of smart mapping before, and when we talk about these stops and unique values and class breaks and these values that you map between, or you're trying to map certain colors to certain values, like Jeremy said, there's a lot of guesswork involved in that, and in order to get a good visualization. And a lot of times, even when you come up with a good visualization, it turns out to be an inaccurate picture of what's really going on, and you're lying with your visualization. And smart mapping aims to help take that guesswork out, so it's being smart for you. You don't need to guess the values as much. So this was introduced in the 3.13 version of the API, and in 4.2 of the 4X API. And like I said, it takes the guesswork out of which colors to use as well. So we have a number of different base maps in the API, but if you use a continuous set of colors on one base map, they might look really bad on another. Like dark blue, for example, does not seem to work well on a dark gray base map. That looks better on a light gray. And so it's not going to give you that option. It'll give you the best possible color for the base map. And same goes with opacities and the sizes for lines. If we've seen a lot of maps where the outline of the feature tends to dominate and take away from the actual visualization going on, and so smart mapping gives an optimal outline size that puts it in the background, so it's there and it serves its purpose, but it doesn't dominate. And like when we were talking about scale dependency, you saw how tedious that can be with those objects. You pass in, an object with 5 or 6 stops that says different map scale values, and then you have different pixel values for the size of those min mark, and that's just for one, end of it, the minimum size, and then you have the maximum size, and nobody really wants to do that. They don't want to figure that out on their own, and so smart mapping will generate that for you. And so the way it does that is we have styles that have been included in the API. And I don't know if you want to talk to this point, Jeremy, but then we also use statistics as well.
Sure. We have a set of color themes. These color themes are I would say best of breed. They're from Cynthia Brewer, Mark Harrower, and others who've Andy Skinner, who've done amazing jobs creating color schemes that work well on different base maps, highlighting different things. A lot of them are colorblind friendly, not all of them, but a lot of them are colorblind friendly. And so this, in this case, the styles module is where you have access to all of the core pleth styles. That's kind of like at the lowest level. Then smart mapping also needed to generate a bunch of statistics because it's all driven from the data. So the feature layer has this is 3x code snippet for sure. It's a feature layer statistics API that has functions to, let's say, get the unique values, and there's a whole bunch of things that it can do. So get the class breaks, get field statistics, get heat map statistics, generate a histogram, sample the features, suggest a scale range, get unique values. Actually, these methods are all very useful in general in the API, even outside of smart mapping. And then from there, we have a set of high-level functions to create a class color renderer, or to create a size renderer, which would be a continuous size. And basically, if we look at one of those, create color renderer, it takes a set of parameters like the base map, the field that you're interested in mapping, of course the layer that you're working with, potentially some other color schemes. And from there, it's going to give you back a renderer that's all ready to go, and you can just set on the layer. And in what we have in ArcGIS Online with regards to smart mapping is a set of sliders to work through all of these different parameters. These are all widgets, and they're definitely all in the 3x API, and some of them are in 4x, especially the ones that are used in the scene viewer for 3D smart mapping. And over the next year, we'll get more of these in place in 4. And then switch over to you.
Yep. So, like we said, it takes the guesswork out. I can show you a little bit of an example of when you might use it in an app. This is a little different from the one you saw in the image. We actually have a demo theater. Both Jeremy and I will be there a half hour after this one's over, so at 2:30 in Demo Theater 1, where we're going to focus on using smart mapping and custom apps. So I'll go into this app in detail, show you the code that is used to create these visualizations, and how you can hook in the render with the slider so that when the user slides this, they can change the visualization on their layer. So what's going on here is this layer actually has a different renderer set to it by default. You don't know that because I am using smart mapping to generate that render based on an attribute that's set by default. So in this case, the percentage of the population in Mexico that didn't go to school, but I could change that to say the percentage that went to primary school, or in the United States that would be elementary school. And you can see that the statistics come back and then they're reset on the slider, and the histogram changes. I get a new average value. And so you can use smart mapping to generate these visualizations for you. It's a pretty good looking visualization already, but it may not work. You may change it a little bit like that to see more of these, to get more nuances from your data. And but you don't always want to use this in your apps. You don't want to just call the smart mapping function every time just because it takes the guesswork out. This is something you do for specialized use cases like exploring your data or trying to find the appropriate renderer. Once you get that, you can either export it as JSON and bring it back in some other way. But as Jeremy alluded to at the very beginning of this presentation, you can go into ArcGIS Online and do this already. These tools are built into ArcGIS Online, and that allows you to explore the data with the sliders, and then you can save the item there, and then you can bring that into your app.
So like Kristian said, these are all built into online. I like to, so you can interactively work with it. Same tools that we use in the map viewer and then in the scene viewer, you can use those in your applications. Now the goal is to help you generate the best possible visualization, but it's everything that we just showed there, it's computationally expensive. There are complicated queries on the server, we got to do sampling on the client. So it's not for every application. I think there's really just two types of applications that would use these tools. One is an authoring app like the map viewer or scene viewer, which needs to let someone explore and author the data. And another one is like the app that Kristian just showed you, which is like purely an app built for data exploration.
Yep. And so yeah, that's what we had prepared today.
Kristian, before you go on to that one, do you have your do you have that layer list example with all those different visualizations in Mexico?
Yeah. Let me find it.
Felt like we didn't, like really show off some cool looking maps.
So let's take a look at, give you a preview of an arcade one. So renderer list. Okay. So something that's really cool about the 4X API or 4.3 is that you have this notion of actions, and you can use actions in pop-ups and actions in the layer list widget now. So this is a layer list widget. If I collapse this, you can see it just toggles on and off the layer in the view, the visibility of it. But an action is essentially this little icon that it makes available on a layer by layer basis, and you can use when it's clicked, you can execute custom behavior. So in this particular app, I am bringing in a web map. So all I did was I copied this layer of Mexico 12 or 13 times, and then I changed the visualization, just explored it and found some interesting visualizations, say maybe the percent of the population that didn't go to high school, and then also using size to show the total population. So while this one uses the same variables, I look at this legend and say, whoa, there's almost 100% of some municipalities didn't go to high school. That's crazy. But it turns out that when you add the size visual variable as well, you notice that those tend to be rural areas. There's not very many people there. These bigger circles indicate that those people probably did go to high school, or most people in the country did. This is a predominance map. I find this one really fascinating. Shows the highest educational attainment for each municipality. So the most commonly attained education level. So you see a big variety of them, and around Mexico City, if we go deep in there, there we go. You see high school is on the outskirts, is the predominant educational attainment. Then there's middle school, and then you go deep into the city, and then clearly most of the people went to college, got a college degree. But then even if you go out a little bit, you see areas here where the highest attainment is that they didn't even go to elementary school at all. They didn't even go to preschool. They didn't go to any school. So you see all sorts of different patterns in Mexico for educational attainment, which I think is fascinating. But you can also add something else like population. So even though there's that cluster down there where most of them didn't go to school, you can see that that's a pretty small population down there. Whereas the cities tend to have highly college, or a lot of people went to college. But even then you see big cities like León or outside of Guadalajara where their highest educational attainment is elementary school. So that's pretty fascinating. But this one I think is particularly interesting. Instead of population, using household size. So then the purple pops out where very large households, so like on average 9.5 people, that's huge, right? And those ones tend to have the lesser educated households. So all I'm doing in this app is I'm bringing in one layer. I'm not bringing in all 13 as it might look like, but I'm grabbing the renderers of the other ones before I load or query that data into the app, and I'm adding them as actions.
I think the main point to show these is not so much on the actions, but just the different visualization opportunities that you have with the API.
So yeah. Yes, this is available on GitHub. In fact, all of these, actually not all of the demos necessarily, but my sessions, you can go to GitHub, conferences, Dev Summit 2017, and you can get the source for all my demos here. So that one came in my arcade session. This is coming up tonight. I really encourage you, because we got some cool visualizations for you there as well. So the slides for this presentation are here in this part of the repo as well. So yeah, all the sources available.
Cool. Anybody have any questions? All right. Quiet.
All right.
All right. Thank you.
Thanks.